Our brains are made up of molecules, each one moving in a deterministic way in accordance to the laws of physics. So, does this mean that our consciousness, our minds, our decision making, our very free will itself is bound to those very same laws of physics? If so, and our consciousness is simply following deterministic laws of nature, why is it that we experience that we have our own agency? We have a conscious, subjective experience in which we feel as though we are making these decisions, not that they are simply made for us in a deterministic mechanism. Why is that, and how does that happen? Well, several experiments in split brain conditions help to elucidate the answer and the actual mechanism by which the story that our brains tell ourselves is created. The psychologist Roger Sperry won the Nobel Prize in 1981 for pioneering research in split brain conditions. And it's his research that offers us the first clues about this process. There's a procedure for epileptic seizures in which the corpus callosum, which is the connection between the right and left hemispheres of the brain, is severed, and thus seizures that originate in one hemisphere are no longer able to spread to the whole brain. The two halves are effectively severed. And in a groundbreaking series of experiments, Roger Sperry noticed some very bizarre behavior in these split-brained patients. Namely, when these patients were shown images or words to just one side of their brain, for example, the left eye corresponds to the right hemisphere of the brain, and vice versa. When the right brain was given a certain stimulus, like a picture of a bell or a snowy field or a saw, the left brain would not be aware of this information at all. There was no communication between the two. And the left brain is responsible for a lot of vocalized speech and, it seems, conscious awareness. When you ask these patients what they've seen, they couldn't tell you. They haven't seen anything. Nothing in their conscious awareness has seen what the image is. However, when you ask them to point to something or to draw what they saw, suddenly their body is able to do this. They're able to point to the shovel that corresponds with the snowy field. They're able to draw a saw even though they don't have any conscious awareness of having seen one.
What did you see?
Saw a hammer.
So just close your eyes and draw with your left hand. That's nice. What's that?
Saw?
Yeah. What'd you see?
Hammer.
What'd you draw that for?
The most curious of all is that when asked why these patients behaved and responded as they did, they either don't know or they will tell you a story like, well, I chose the shovel because the previous image I remember seeing with my left brain was a chicken and I need the shovel for the chicken coop. Or they'll say that they just happened to see a bell on their walk to the lab. They will construct some sort of rationalization, some sort of storytelling to explain why they did what they did, even though in reality we know that their behavior was simply a response to the stimulus that they themselves were not consciously aware of. Sperry's work was continued by his graduate student Michael Gazzaniga, who continued to probe and discover more about these split brain syndromes and what it means for more generalized human conscious experience. Gazzaniga hypothesized that somewhere in the left hemisphere of the brain there was an interpreter, a brain region, a neural circuit that was responsible for compiling all of the various information from the different areas of the brain into a unified story that is then experienced by the person as their own subjective conscious experience, the story that our brains tell ourselves. This would explain why in split brain patients, where the right hemisphere is physically isolated from the left hemisphere because the corpus callosum is severed, it would explain why these patients are not consciously aware of the information in the right hemisphere, that information that's fed in from the left eye. Now, these patients are still unconsciously aware of that information. They're able to respond and give back that information through pointing with their body or with writing it down, but they don't consciously understand why they are writing the things that they're writing. And the left brain interpreter creates a story to rationalize why it is they're doing what they're doing. Now, the actual component brain regions that make up this neural circuit that Gazzaniga and I have been calling the left brain interpreter, responsible for explanation generation in our decision making, is made up by a number of different component brain regions, such as the left lateral orbital frontal cortex and ventrolateral prefrontal cortex, involved in generating causal inferences and explanations of events, and are then evaluated in the dorsolateral prefrontal cortex, as well as the anterolateral prefrontal cortex. So this is not just one region in the left hemisphere. This is dispersed around many regions in the left prefrontal cortex. But these experiments have implications outside of just split brain patients. This applies to the human condition and how each of our brains construct our conscious subjective experiences more broadly. And each of us has experienced this for ourselves in dreams, for example. Dreams are constructed out of the background information and thoughts floating in the very periphery of our minds as we are asleep. The left brain interpreter, this storyteller in our brains, will latch on to certain concepts and thoughts as they pass through the backgrounds of our minds, and it will sew them together into some sort of narrative. Many of you are familiar that this narrative does not always make sense. Some people refer to dream logic. Oftentimes, it only makes sense within the context of the dream, and only when you're not thinking about it very much. I know my dreams are personally chaotic nonsense. This is the left-hand interpreter constructing these narratives out of mostly disparate thoughts that it's linked together to create some sort of conscious experience, aka our dreams. Subsequent studies in the 90s experimented with electrically shutting off one hemisphere or the other and seeing how patients handled syllogisms. And they noticed that when the right hemisphere was shut off, and it was just the left hemisphere handling these logical syllogisms, it was apparently not able to rely on past experience to fact check what this brain was constructing, what these logical arguments were leading to, and oftentimes the conclusions were just nonsensical. However, the patients did have a logical narrative story about how they got to those conclusions, and they were convinced that they were accurate. And the opposite happened when the left hemisphere was shut off. When it was just the right hemisphere handling these syllogisms, it was almost incapable of abstract thinking, purely relying on familiar past experiences to generate conclusions. If the syllogism was some unfamiliar concept, the patient was simply unable to engage with it. In normal brain anatomy, where the corpus callosum is not severed, these two disparate hemispheres work together, and they're two divergent modes of thinking. Each fact check one another to get the most optimal responses that both are capable of abstract deductive reasoning as well as more grounded past experience to inform our decisions in a grounded, realistic way. Gazzaniga hypothesized that there's an evolutionary advantage to having these various mechanisms in the brain separate, these thought processes, these divergent modes of thinking in separate regions. And that's that you can have mutations that could affect one circuit while keeping the other intact, and thus you can have a wider array of different overall ways to process information. In fact, after 40 years working in this subject, Gazzaniga even hypothesized that there's not just two of these brain regions working with divergent mechanisms of arriving at conclusions and assimilating information. There's actually several all over the brain. The brain is more of a constellation of different semi-autonomous independent agents or mechanisms going on of thought processing. And then all of these various semi-independent neural circuits are then integrated by this left brain interpreter to construct a unified, coherent narrative by which we're able to understand that process in a subjective experience. So when we're making a decision, say to choose between a red jelly bean and a blue jelly bean, our neural circuitry is going to take in that input stimulus, is going to be processed in numerous different regions of the brain through semi-independent processes, then synthesized to create a response. A decision is made. However, all of this appears to be an automatic process, following the basic rules that govern the behavior of neural circuits and ultimately the causal movement of molecules. So where does our conscious experience of, well, I made the decision to choose the red jelly bean come from? Well, that is the left brain interpreter creating a story that we can tell ourselves about why we chose this decision. The decision was made in an automatic, mechanistic process going on in our brains outside of our conscious awareness. But our conscious experience is created out of this left brain interpreter, this story, this narrative about why we made that decision. What was our justification? What was our thought process, our rationale? And that thought process doesn't necessarily have to have anything to do with the actual mechanisms which are dispersed through various different brain regions and different neural circuits, each then synthesized to create an overall response, which we can then interpret in a way of narrative construction to say, here was what I was thinking, here's why I made that decision, and this is comforting to us. We have some sort of sense of control or agency over our decisions. That's why we tell ourselves these stories. But we should keep in mind that when this left brain interpreter is severed from the right hemisphere and left to its own devices, it can often run amok and create huge biases or holes in our reasoning because we can become so convinced of the stories that we tell ourselves that sometimes we will ignore the actual evidence in front of our face, the reality that might be different to the stories that we tell ourselves. Most people are uncomfortable with the idea that our decisions are ultimately automatic, that they're determined by natural laws and not by any actual free will, and that this free will is a necessary illusion for being a functioning, subjective, conscious being. It's almost impossible to think what our day-to-day lives would be like if we did not have this left brain interpreter constructing these narratives for us to explain our thought process and our decision making. It's almost so intertwined at the very foundations of our conscious experience that I certainly cannot imagine how it would be otherwise. Free will really does seem to be a necessary illusion to function as a conscious being. But the laws of physics, as well as what we've seen experimentally in cognitive neuroscience, has shown us that it is only an illusion, that our brains are automatic, and our sense of free will, and perhaps even our own conscious subjective experience in its entirety, is an illusion created by our brains for the purposes of optimizing our adaptive function with our environment. Thanks for tuning in to another based theory. And remember, stay learning, stay curious, and subscribe for more.